Hello, students. We are looking at the solids in the chapter of surface area and volumes. Now is the time to move to the next solid, which is a cone. And we are going to begin with looking at the net of a cone.
Net of the cone. Here I am going to tell you about the nets of a cone. Look at the birthday cap. When you open this, you get a portion of a circle as shown here. This is called the sector of a circle. Now, if you fold the sector in such a way that the two straight edges meet, you will get the shape of a cone. But if you want a closed cone at the bottom, you will need a circle and its perimeter will be the same as the arc length of the sector as shown. And this is nothing but the net of a cone.
All right, so what you have just seen can be taken up as an activity at home. You can cut a circle, and from the circle, you can cut out a major sector. Bring the radii of the major sector together. The shape that you obtain is called a cone. So you can make your own birthday caps as activity at home. Now here we can see a sector of a circle. The length of the arc of the sector converts into the circumference of the circular base of the cone, and the radius of the sector becomes the slant height of the cone. The slant height is denoted by the letter L. And as you can see, the height and the radius are perpendicular to each other, which is giving us a right angled triangle over here. Before I discuss this further, I'm going to talk about the curved surface area of a cone, which is equal to pi r L. And the total surface area of the cone is equal to pi r L plus the area of the circular base, which is equal to pi r square. Combining the two, you get the total surface area as pi r into L plus r. But how do we obtain the value of L over here? Now, this right angled triangle, which I spoke about, you can apply the Pythagoras theorem in a right angled triangle, where L is the hypotenuse and H and R are the remaining two sides of the right triangle. So when you apply the Pythagoras theorem, you have L square equal to H square plus R square, and L can be written as square root of H square plus R square. Let's look at some real life examples of a cone. Here you can see birthday caps, you can see corn cobs, you can see a road divider cone, which is used to divide the lanes while we are driving on the road. This is a conical funnel, and these are waffle cones that you all enjoy in summers. We are going to move to the next exercise of the chapter, which is 13.3, and I'm going to begin with question number 3. Curved surface area of a cone is 308 centimeters square and its slant height is 14 centimeters. Find the radius of the base and the total surface area of the cone. So CSA of the cone is pi r L. That is going to lead to 308 equal to 22 by 7 into r into 14. Now what we observe here is that 14 can be cancelled with 7, leading to 2. And after the calculation is done, r is going to be equal to 7. So the radius of the base is 7 centimeters. The total surface area of the cone is equal to pi r into L plus r. Put the values, all values are now known, which is going to give the TSA of the cone as 462 centimeter square. Next, we move to question number 4. A conical tent is 10 meters high and the radius of its base is 24 meters. Find the slant height of the tent and the cost of canvas required to make the tent if the cost of 1 meter square of canvas is rupees 70. Now here the question says conical tent is 10 meters high. Whenever the word slant is missing, the height always means the vertical height. So here h is equal to 10 meters. That means the values of h and r are given to us. Substitute the values of h and r in the formula for L, and that will give you the slant height of the tent as 26 meters. Cost of canvas required to make the tent is going to be equal to the CSA of the cone into 70. Why CSA of the cone? Because when you put tents on the grass, the circular base is never there. So it is just the CSA of the tent, conical tent, which is counted. That's going to lead to pi r L into 70. And after you have done the multiplications, you get the cost as 1,37,280. Next, we move to question number 5. What length of tarpaulin, 3 meters wide, will be required to make conical tent of height 8 meters and base radius 6 meters? Assume that the extra length of material that will be required for stitching margins and wastage in cutting is approximately 20 centimeters. The value of pi has been specified in the question as 3.14. Now the width of the tarpaulin is given as 3 meters and the vertical height or h is equal to 8 meters. So the slant height can be calculated using the height and the radius, which is giving you a value of 10 meters. The length of the wastage is 20 centimeters, and since the conversion has to be in meters throughout, you will have to write down the wastage as 0.2 meters. Now, area of the tent is CSA of the cone, which is pi r L, and I'm substituting the values. The area is in meter square. Now, what do you observe here? I haven't calculated the area of the tent completely. That is because we don't need the value of the area in the question. Multiplying it will make the cancellations difficult in a later stage. So length of tarpaulin is equal to area upon width. That is the area you have just calculated upon the width, which you've written earlier. See how easy it is to cancel 6 and 3 now. If you had multiplied, cancellations would have been difficult. That's going to give you the length of tarpaulin as 62.8 meters. But that's not the complete length because the wastage also needs to be added. So the total length of tarpaulin is equal to 62.8 plus 0.2, which is 63 meters. Question number 7 is for you all to try yourself, and I'm leaving it with a hint. How do you interpret a cap in terms of the area? Question number 8. A bus stop is barricaded from the remaining part of the road by using 50 hollow cones made of recycled cardboard. Each cone has a base diameter of 40 centimeters and height 1 meter. If the outer side of each of the cones is to be painted and the cost of painting is rupees 12 per meter square, what will be the cost of painting all these cones? Use pi as 3.14 and take root of 1.04 is 1.02. Now, when this value of root of 1.04 is given to you in the question, it is a clear indication that somewhere in the working of the question, this value is going to appear. Now, the radius of the base is 20 centimeters, which is being converted to 0.2 meters. Height is already in meters. So the slant height of the cone by the formula is root of 1.04, and the value is already given to us in the question. So that's 1.02 meters. What is the area of 50 cones then? That's equal to 50 into CSA of one cone. Substitute the values and multiply here. That's leading to 32.028 meters square. Now, what you can see over here is 3 decimal places. I can round this off and write it as 32.03 meters square. What are the rounding off rules? I'm just going to revise that for you. If the value is 5 or more than 5 in the end, then the digit before that increases by 1. If the value is from 1 to 4, then the digit before that does not change, it remains the same. But over here, since the value is 8, you can write the answer as 32.03 meters square. So what is the cost of 50 cones? Multiply the area with 12 and you get 384.336, which is 384.34 meters square approximately. Why am I not rounding off here, but only the final answer? Because when you start rounding off at every step, then the final answer will start getting affected because your approximation starts at an early stage. So it's best to round off the answer only in the end. Now, questions 1, 2, 6, and 7, you will try yourself. And this is the challenge question for this solid. It says the height of a solid cylinder is 15 centimeters and its diameter is 7 centimeters. Two equal conical holes of radius 3 centimeters and height 4 centimeters are cut off. Find the surface area of the remaining solid. So over here, you can see a cylinder with the height equal to 15 and the diameter equal to 7. Now, these are the conical holes which are removed from the solid cylinder. Both the cones have the radius equal to 3 and the depth or the height equal to 4 centimeters. You have to work out the surface area of the solid which remains after the cones have been removed. So that's it to this video. Thank you all. I'm going to come back with the next solid in my next video.